This is the application of VBT theory. According to VBT theory, we can determine the hybridization and structure and magnetic property of a given complex. Here tetracyanonickel 2 complex given here, tetracyanonickel 2 ion is given. So according to this one, what is the central atom? This is the neon is the metal atom. Neon is the 28 configuration. This is the argon 4s2 3d8 is there, that is the oxidation state is +2, so nickel +2 oxidation, that is the configuration here. Actually that is the nickel 4s2 3d8 configuration. When the oxidation number 2 lost the 2 electrons in the nickel, so 4s electrons is removed, d8 configuration takes place. So here electronic configuration, finally we conclude that one, nickel 2 plus 3d8 and 4s0 4p0. So here how many ligands is there? 4 ligands is there, so 8 electrons coming. So these are also strong field ligand, so electron pairing takes place. Here due to the presence of strong ligand cyanide, unpaired electron get paired and vacant orbital undergoes to which hybridization. So in previous manner we discussed the coordination based on the coordination number 4. So the complex get the sp3 hybridization or dsp2 or sp2d hybridization. So here strong field ligand, so inner orbital also involving the hybridization. So the hybridization, here the which hybridization, sp2 or dsp2 hybridization taking place. That point you have to remember here. Next one, just we have to see here, to these orbitals cyanide donate their electron pair from the square planar structure. Electron configuration of nickel, that is the IR, we have to shaking the pairing of electrons to orbitals here involving here is the dsp2 hybrid orbitals formation, one d orbital remaining. This is the s orbital and p2 orbital, dsp2 hybridization. The structure of this complex is the square planar. So pairing of electrons, diamagnetic nature, the complex nature is. So this is the based on the VBT theory, easily we can determine hybridization and geometry of the complex and magnetic nature also. So diamagnet based on the unpaired electron, the magnetic nature we have to discuss it. So just we have to observe this table. For example, unpaired electrons present, one is there, one electron is there. So in that situation, just we have to see that is the, here 1 is there 1.3, 1.73, 2 electrons is there unpaired 2.84, 3 means 3.87, 4 means 4 means that is the 4.90, 5 means 5.92. So respect to unpaired electrons, you have to remember respect to unpaired electrons as the, remember magnetic moment also remember. So here we have to see scandium to zinc configuration also you have to remember. Scandium 21 simple, you have to put organic, that is the 18. Remaining here one concept you have to remember here. 21 means here 21 means 2 1, 22 means 2 2, 23 2 3. So exception here case, that is chromium, one concept copper only exception. That the configuration actually 4s2 3d4, but off field concept, so s electron promotion to the d. So that's why 1 electrons come here and d 1 electron here. So that exception case chromium and copper you have to remember. Remaining all simple. 25 means 2 5, 26 means 4s2 3d6, cobalt 2 7 means here 4s2 3d7, nickel and copper exception s1 d10, zinc also s2 d10. This table also you have to remember when we are going to explanation of VBT theory or complex nature or magnetic nature and electron configuration also. Most useful you have to remember, and have to remember this is a table form, that point you have to remember. Take the next one here. So another compound we are going to see, that is the hexacyano here, hexacyanoferrous 3 ion. This is the ion above complex is the metal ion. So which oxidation, that is the 3 oxidation number, 6 minus 3, that is the 3. Iron is the 27 is there here, iron 26. Here 3 oxidation number means 4s2, here 4s2 3d6, lost the electron, 2 electrons here, 1 d5. Finally iron plus 3 d5 configuration here, d5 4s0 4p. That is the, in presence of cyanide ligand electrons pair takes place. So due to that one, which hybridization 6 means, that is the sp3d2, but here inner orbital taking place, that is the coordination is sp3d2 but cyanide ligand d2 sp3 hybridization taking place. Shape of that complex is the octahedral shape. The magnetic nature, what is the magnetic nature, how many electrons is there? 5 electrons, 1 electron unpaired electron, so 1.732, so Bohr magnetons. That point you have to remember. This is the complex hybridization. What is the octahedral shape? That is the octahedral shape we have to remember. That is this is the complex hybridization and geometry and paramagnetic nature. This is